Yeah, we're all welcome to this tutorial. I'll be looking at one-way ANOVA. ANOVA is spelled A-N-O-V-A. Yeah, that's ANOVA. It's supposed to be in capital letter. So this ANOVA, this is what we're looking at. ANOVA. All right. So we're going to go straight. We'll not waste of time. Now it's called analysis of variance. Analysis of variance. Let's say you're an experimenter and you really want to test to know the effectiveness of three methods of teaching. As we know that there are several methods of teaching, you want to know the one that is of optimum impact on the students' final performance. Now we're going to get like a group of 24 subjects, that we're going to really test these methods on. And this group of 24 subjects, we're going to have three subgroups, and these three subgroups, comprises of 8 subjects each. This will have 1, 2, 3, 4, 5, 6, 7, 8. The 1 represent the method 1, and the 2 represent method 2, and the 3 represent method 3. And each of these group or subgroups comprises of 8 subjects. So let's say upon completion of the course, each of these subgroups, is going to be given a common test, like an exam, covering the material in that very course. And at the end, as an experimenter, you want to really know, with their test course, you want to know which of the method is effective. All right, so we're going straight. We'll have our analysis of variance. Come to analyze, go to compare means. When you go to compare means, we go to, we have what we call dependent list and factor. So dependent list. Your dependent list is the score, because the output, the score of the student is dependent on the method that was utilized in teaching them. Then the factor, now you click here and you push this arrow. The factor is the method, can also be referred to as independent, because this is what you are applying. These are what you are applying, or the method you are putting forth to see the student's performance. Then after done, you first click OK to get a test of significance. Now I say OK. Then you come here, and mind you, our significance level is 0.05. When you hear the word 0.05, or you hear someone say a statistician say 0.05 as level of significance, means that any significant level you get that is above 0.05, you can say that statistically there is no significance. But any significance level that is less than or equal to 0.05, you can say that there is a statistical difference, significance, in that value. All right, so after testing this, let me open up this. You come over here, the significance between groups and within groups, the significance is 0.013. And if you look at this, this is below 0.05, meaning that there is a significance, in the test scores or whatever values that you have evaluated. Now, since there's significance, we really want to know now, okay, this is a general, significance among the 3 subgroups and whatever you've done to your data. But now I want to now check between the group. We want to know what is going on in the level of significance between group 1, between method 1 and 2 and 3, between method 2, 1 and 3, between method 3, 1 and 2. So what we do, we go back to where we have our data view, and we're going to look at analyze and compare means. We'll come to our one-way ANOVA, and then before we can run OK, we'll go back to a postdoc. We'll go to our postdoc. Yes, we want to really know between the groups or between the methods, and to see whether there's a significance. So we're going to go to our postdoc, multiple comparison, and then after choosing your postdoc, you choose our Turkey. Yeah, you choose our Turkey test. After running our Turkey test, look at the significance level is 0.05. Then we'll now say continue. When we say continue, you now say OK. Now let's expand this and then come over here. These are post hoc tests. Now, if you notice something, take your attention should be drawn at this asterisk. This asterisk, the star there, means the mean difference is significant at the 0.05 level that we have set. That's the significance level. So let's go on. These are method 1 against 2 and 3, method 2 against 1 and 3, and then one method 3 against 1 and 2. We are testing to know if there's a level of significance between these teaching methods. So I'm taking teaching method 1 against teaching method 2 and 3. Coming to the significance, 1.0 is higher than 0.05, so there was no significance. Yes, but coming to here, 0.02 is less than 0.05, which is as level of significance, meaning there was a significant level, there was a significant difference in method 1 when compared to method 3. If you notice, there's an asterisk here telling you that there's a significant difference between method 1 and method 3. So now let's go on to method 2 against method 1 and 3. Tells you there's also a level of significance here. We go look at it, 0.025, but here is 1.00, which is higher than 0.05. Then coming to method 3, method 3 is showing a significance in both method 1 and method 2. Meaning when you're comparing method 1 and method 2, when you're comparing method 3 against method 1 and method 2, method 3 has a significant difference when compared with method 1 and method 2. All of them are having 0.25, 0.025, and 0.025, meaning that the mean difference is significant at the 0.05 level, which is our level of significance. Meaning, as an experimenter, you are to go with this method 3. Yes, method 3 is very, very significant. So you can actually come up with a write-up advising the school administrators that, this is what I've come up with, and by all indications, teachers or lecturers should stick to method 3 as the best method in teaching the students, because with that method, there will be high performance, in their output. So this is what analysis of variance helps us in doing. Okay, beyond that, after doing a multiple comparison, this is a multiple comparison we've just done. Now, we can still go back to what they call the homogeneous subset. Yes. These homogeneous subsets now here we have a method 1, 2, and 3. And we have subset for alpha. Alpha is your level of significance, which is 0.05. So from the values and from the significance level we got from here, we're going to test. Yes. Now, we can assign 1 and 2. This is divided into 1 and 2 to tell us the homogeneity of the methods that have been used. Now, for each of the column, you see that method 1 is under the column 1, which is 1. Method 2 is under also the 1. What is it telling you? It's telling you that both of them, are bearing the same subscripts or superscript rather. Meaning, I can assign a superscript A here and a superscript A here. And what does that tell you? A can go for 1 and B can go for 2, however you want it to be. Now, for this method 1 and method 2 to be on the same column, which is 1 or which is A, I can assign superscript A here and superscript A here, telling my whoever I'm analyzing the data for, or telling myself that these two methods, 1 and 2, there's no significant difference between them. Looking at method 3, the value is under column 2, which is the B column, meaning we are going to assign a superscript of B here. What does that explain? It tells us that there was a significant difference between this method 3 and method 1 and 2. This explains what this table, the multiple comparison, told us. Meaning, method 1 and method 2 are assigned, superscript A and AA, meaning there's no significant difference between them. But method 3 is assigned under group 2 and assigned the superscript B, meaning that there's a significant difference between the method 3 and the method 1 and 2. So that's the homogeneous subset as displayed there. So this is very, very important for researchers and for experimenters, to test a lot of things, to check for the levels of significance. So I think this is okay. So feel free to ask your questions in the comment section and I'll come through for you. Thank you so much.